Hello, my name is Rich Howard, owner of Architectural Builder Supply. This video is to bring you a closer look at the Hager number 730S. This is a silicone mill finish automatic door bottom. This happens to be a 3-foot unit for purposes of this video, and let's take a closer look at what the 730S is. I will mention several times in this video that automatic door bottoms are an elegant solution to being able to seal off the bottom of a door. This is a particular type, meaning that it gets mortised to the bottom of the door. The 730S is representative of the fact that this is a mortise style. You get the idea from looking at it in its cross section that you're going to create a mortise so wide, so deep. This will get pushed into the cavity that you've created, the mortise you've created, and the rest is relatively elementary. So this is a mortise style, and that's important to know because there are more than one style. There's surface mount, which is the most common. You can take that surface mount for type 2 and then mortise it flush to the face of the door. That's a nice option that will occur in hotels because the door bottom doesn't encroach into the opening because according to A117 ADA compliance, that's projecting into the opening in such a way that would not be permissible for handicap compliance. Mortise style, of course, are completely concealed, so that's not a trouble there at all, which is the third type. Surface mount is by far the most common. Mortise style number 2, then mortising flush the surface mount would be the third type. Not really common, but it would sure be a nice way to do it if you were dealing with a surface mount model. So be mindful, those are the 3 types typically seen. This and all other automatic door bottoms really operate on the principle of this bolt is attached to a flat spring. When the bolt is pushed in, the flat spring bellies, forcing the bottom seal, the drop bar, to drop. That's how these all work. Almost all instances of automatic door bottom surface mount or semi-mortise will mount on the push side of the opening. There is a way to make them work on the pull side if you needed to. We can help you with that. The mortise style, that just gets mortised to the bottom of the door naturally. Now, how do these work? Well, you'll study this end and you'll see that there's this bolt that's hanging out here. The more that I turn it clockwise, the less it sticks out. The more I turn it counterclockwise, the more it sticks out. That projection is directly related to the amount of drop that the door bottom will engage in. The other side has nothing there. There's no bolt. This is always the lock side of the door. This is always the hinge side of the door. And we're going to get into the installation instructions and we'll talk about the installation of it and how to prep the door. But how these work is once you've prepped the door, you've installed it into the door, you've secured it with the screws and this flange. This is sticking out of the hinge side of the door, right? Okay. This is on the lock side. Well, when that bolt is hanging out of the hinge side and the door is open at 90 degrees, it's sticking out. Now, in your mind's eye, imagine as you close the door, that bolt sooner or later is going to make contact with the jamb. As you continue to push the door closed, that bolt has nowhere to go but in. As it goes in, that's where the bottom's going to drop. Okay? So my hand over here has pushed the bottom in, and you'll notice that it drops uneven, and that's absolutely by design. I've had customers call me and say, hey, your automatic door bottom doesn't drop even. No, it shouldn't. Or at least the one you bought shouldn't. There are those that drop down evenly that you would have in a sliding door. Those need to drop down, and there are others that do as well. But in a swinging application, when that door has continued to be pushed closed, the bolt touches the frame. It has nowhere to go but in. As you continue to close the door, now the bolt is compressed as is permissible based on the amount of projection that you've set. You now have a sealed door. Why does it drop unevenly? Well, you'll notice that it drops first on the hinge side of the door. Okay, now imagine, in your mind's eye, imagine this. As you start to close the door, it starts to make contact, and the door is still ajar, let's just say 10 degrees. You continue to push the door closed, it will continue to drop until at such a point where the part over here on the hinge side makes contact with the sill. It can go no further once it touches the floor, the sill, the threshold. As you continue to push it closed, now what happens, my thumb is going to act as the sill. Okay, I'm gonna use my thumb to act as the threshold, and you can see how it then will come down and even out over here. That's how these work. The leading edge of the door is still in movement. You don't want that part of the door bottom touching the floor and then being dragged across the floor. You literally want this to drop and then close. Okay, so I'm open to about 10 degrees, just using it, drops and then closes. That's how these are meant to work. So be mindful of that. If it's working that way, then it's working correctly. The amount of projection is directly related. We'll talk about the drop when we go through the extended description. When you set the projection, you don't of the bolt, you don't want that sticking out any further than necessary. Having an undue amount of pressure or compression on that flat spring pushing the bottom down is not a better seal. You want it to drop, make contact completely across, no undue contact, and that's the projection. If you set too much, if you back the bolt out too far, and I've had customers call me, I installed it, and the first time I opened the door, the whole door bottom ripped out. I know it causes that, and so we discuss with the client, how did you set the projection of the drop bar? Yeah, I put it all the way out. I want maximum seal. No. As soon as you start to open the door, the drop bolt becomes relaxed because now the door is moving away from the frame. Immediately at that point, you want that bellied flat spring to begin to relax as well, which will then drag the bottom upwards into its housing. You want that immediately to start lifting off the floor so that, just like we don't want it dragging in the closed closing cycle, we don't want it dragging in the open cycle either. So that client literally needed to order an entire new bottom and then just set it so it makes contact. That's all. There is one drawback to these, and by the way, I believe that all of that makes a very elegant solution. There is a drawback to these, and that's as follows. As you open the door, you're going to hear a clanking sound. I've had clients, if I sell 1,000 of these, one person will say, that sound is not going to work. And I didn't really think of it until the first time it was said to me many years ago. And after that, I've been mindful of it, that there is a measurable amount of sound emanating. And that's a result of that drop bar, of course, snapping back up into its housing. Okay. Now, there are models on the market that go a long way to deaden that sound. Hager does not give us any provisions for that, so be mindful, okay, that there is a sound. In a commercial application where you need to seal the bottom of the door, people aren't thinking of that. It's not going to bother anyone. There may not be someone. I've sold door bottoms to people in bedrooms because there's a home where there are bedrooms that are associated in close proximity, and they really need to deaden the sound from each bedroom as best as possible, but what they don't calculate on is the sound of the door opening. So be sure to take that all into account and to consider. Now, if it's an exterior hollow metal door, this wouldn't be for a hollow metal door, but let's say that this was a model for a hollow metal door. It would be the same idea, but it would fit into the bottom of your inverted channel. Emergency exit or in the back of a shop, that sound is not going to be a concern. Unless, of course, it's a recording studio. I don't think that sound is going to be a concern, but be mindful of it. What else makes this very elegant is the fact of the matter that in a door sweep versus automatic door bottom, the automatic door bottom wins. Here's why. If you have an in-swinging door in your home, where are you going to put the door sweep? Well, if you put it on the outside, which is where you'd want to put it, you're going to drag that across the top of the threshold every time you open and close the door. If you put it on the inside to avoid that problem, well, your front line of defense is unguarded. You've got your sweep on the inside. The other downside of a door sweep is that that's hanging off the bottom of the door to a certain extent. It's going to drag across anything that's in the way of the cycle of the opening and closing cycle of the door, like a rug. Okay, if it's a mudroom, yeah, it'd be nice to walk in and wipe your feet off. An automatic door bottom snaps back up into the housing every single time. So you can draw your undercut as low as possible, and you're going to be able to conduct yourself in such a way that you can leave a rug. A shoe can be left behind, or at least something that won't tear up the applied door sweep. I personally like a belt and suspenders type of approach. In that same in-swing application, I would certainly be doing a surface-mounted automatic door bottom because that's on the push side. My line of defense is right on the outside. I might even look to add a drip cap over that so that I can drive any rain away from my front line of defense. And if you wanted to seal off the inside undercut of the door, you might apply a door sweep there as well, a belt and suspenders approach. And I've supplied material to people like that in the past where they've had an extreme leaking condition, northern climate, and you stand in front of those doors and the entire floor for 6 feet is even cold. Because that middle of the winter, middle of the night, air in Chicago is just coming in, leaking everywhere. Put the seal on the outside. Put one on the inside as well. They're really not that expensive. And then when you stand there, you realize, wow, this was really worth doing. That belt and suspender approach. So elegant the way that it'll work. With its one downfall of actually making sound, a door closer makes sound, right? A lever handle makes sound. These are loud, there's no question. Now, let's look at the extended description information down below and we'll dissect the part number. It's an automatic door bottom with a silicone seal. It's made of aluminum and a mill finish. Lengths, we probably have these listed in the site from 2 foot to 7 foot, 6 foot. I don't see why they can't make them especially long, but 3 foot, 4 foot, 2 foot 8. Those are going to be your sizes, 42 inch. Provides an outstanding seal against drafts, light, smoke, and sound. This is positive pressure compliant. It is UL listed, and it is smoke tested. You would be able to order these for your doors that require that compliance with those requirements for positive pressure and smoke. You will absolutely want to order, you'll have to order your doors prepped for these. You wouldn't be able to prep these in the field in a fire-rated door because that would violate the integrity of the door, and plus the door wouldn't be built with the internal components to handle that sort of mortising that you would do. For best results, use in conjunction with a threshold. Sure, give it something to seal against. Absolutely. To a sill that might be there, probably not the best way to go about doing that. The threshold will also close off the undercut from the bottom of the door to the top of the area, permitting less room to begin with, less of a space to have to fill. Okay. Gasket retracts when door is opened. Furnished exact length as stated. That is important. That's 36 and about a 32nd, so it's just heavy, and a little bit of margin is going to be allowed there. The point is lots of weather stripping is generally sent long. If you order a 36-inch threshold, it comes out at 36 and a quarter. These are kind of standard. It's always a good idea to declare when you're ordering what size you want and let the factory cut it to that size. They're cutting these pieces from long components. They're assembling these. They're manufacturing them. So they really wouldn't care if they're cutting it to 36 inch or to 35 and 3/4. So be mindful of that. Order it the size that you need. Maybe trimmed up to 2 inch if you are doing 3-foot doors and you know that they're going to be 35 and 3/4 and you don't want to measure exactly and your guys are going to install them and cut them in the field, fine. You can take 2 inch off of this. The area certainly that you need to be absolutely mindful to avoid, there's some evidence here of the connection of the flat spring on the inside, and you will only ever cut off of the lock side of the door. Okay, only the side without the bolt is the only place that you'll cut from, so be mindful of that. It is, of course, quite normal for the seal to run long. You'll trim that in the field after you get your installation in place. Okay. Sometimes the springs are so stiff that you literally have to put it on your desktop and push down. It does get a bit difficult to push in some of these stiffer springs. So if you get it and you can't push it in with your finger, 2 times out of 10 I can't either. The spring is just too stiff. Furnished with end cover and strike plates. Yes, we will go over that with the installation instructions and screws. Now, let's look at the product catalog to check out the other options that are available on this automatic door bottom. This is going to have a silicone insert. It is also available in the 730 as a neoprene insert. Now, what's the difference between the two, really? This is a sponge type silicone. The difference for me primarily is I find neoprene is better at water intrusion. Neoprene is, and I expect they're using, I don't know if they're using an open cell or a closed cell neoprene. They might be using a open cell where it's spongy. The hallmark of neoprene is that it's used in STC ratings, so it's really good at sound deadening. A bit more rigid generally, and then certainly more rigid compared to silicone. Silicone, I find, is more flexible and more appropriate for high temperature applications. If you are installing doors on a roof of a power plant in the American Southeast, silicone is good because that will be triple-digit temperatures all day long on that roof. And I find that silicone's a bit better at those extreme temperatures or higher temperatures. Closed cell neoprene would be best for water sealing because it's like a wetsuit where there's no possibility of transmission because it's a closed cell structure. The other models that are there immediately take notice of the 743 model. What's the difference? Well, we'd call that one heavy duty only because the surface area of your seal is going to be greater. The 742 is the same model I had mentioned earlier for your hollow metal doors that will fit into your inverted bottom channel of a hollow metal door, which is typical and standard for hollow metal doors. Then there's the 740 and the 747. Those are surface mount models, standard and heavy duty. Either of those you could mortise flush to the face of the door. If you're going to do that, you need to think about how the size of the item that you order will be different. In a surface mount application, you're measuring the distance between the stops and deducting 1/8 of an inch. But if you're going to take that same item and mortise it to the face of the door, now you're dealing with something that's going to be ordered as the width of the door. Now, talking about the size that you're going to order for a mortise like this, you're going to order it the width of the door. Okay, if you're doing 3/0 hollow metal, 3/0 steel frames with wood doors, they're not going to be 36 inch. They're going to be a little bit smaller. Tell the factory. Order the next longest piece or pieces and indicate in the comment field what net length you want it to come out at, and let them do all the work. They're cutting it anyway. No reason to cut it twice. You're not going to run the risk of actually damaging the material by not cutting it, so let them trim it all. Now, the next link below this video is to the installation instructions. There are apparently two versions of it here, a 2018 revision, and the one that came with the package is a 2018 version. We'll get to that in a moment. Product info is there. The product info is an overview of technical jargon published by Hager. I would recommend that you review it. If you work in the construction industry and you do finish carpentry, or you are installing hardware, or you're the hardware expert in your contracting company, review that. There's information there, talks about how weather stripping is used, the different classifications, what all the little symbols mean, talks about fire ratings as well. There's then a document there's a document called template, and that's where we're going to be able to check all of our dimensional properties. Will it work on an 1 3/8 door? Technically it will. You can make it fit. The problem is the end caps are going to be too large. Those aren't going to fit. So if you're going to want this on an 1 3/8 door, you're going to have to do something about those end caps. The factory won't. The overall height, 1.8 inch. Okay, so basically 1 13/16. Dimension from the underside, going to be about 1 3/4. They got 0.65, so just heavy on 5/8 thickness. Okay, so how are you going to mortise this? Well, how are you going to mortise it? First of all, you're going to look and see if you have a tool that you can use to do it without having to buy a tool. That tape measure shows me that I've got maybe 1/8 of an inch to where that first screw is going to hit. Okay. So let's say that it's 0.65, and you know that you need to create a prep to fit that in. And you don't have an 11/16 mortise bit, 2-flute carbide router bit. The question is, will 3/4 inch work, which you might have, or be able to use in the future? You know, if you've got 1/8 of an inch from the wall and you're trying to get to 0.75, you know, those screws get awfully close. I would, you know, because that's another 100 thousandths. 1/8 of an inch is 125 thousandths. Is it going to work? Yeah, it will. I would really prefer to be as tight in there as I could on the prep. I always say that the caliper is the carpenter's second best friend. And that's because it is. They say 0.65. Okay, great. Well, they're not here prepping the door. I am. Put my caliper on here. What are we actually dealing with? 0.647, 0.65, 0.646. So you know that you've got a hard 0.65. So now you've confirmed what you're dealing with. And you might just get yourself the right size bit. I would be looking to be at the 11/16, so I don't have, so that my screws are not close to that wall of where I'm going to breach through into nothingness. And then your depth, yeah, 1.75 really, you know, closer to that, less this. You're going to make your depth 1 3/4 deep, and that's all there is to it. Now you can start to see why you need to think about the door when you're ordering it and letting them prep it. Well, you might have the tool to route it, and you have the technical understanding of how you'll approach routing it. But what if the door is just all particle board inside of there? You know, do you really want all that particle board just flaking out over time? If you're going to prep it into your own door, the problem with doing that is you don't have anything integral in terms of a structural member of the door that you're going to leave. So if you're going to if you're going to mortise it yourself, order a 6-inch bottom rail, or let the factory prep it, or, you know, you're putting it into an existing door and it is what it is. And if that's what you're going to do, I would recommend that you get inside of that and fill up with polyurethane so that the particle board, if that's what it is sealed. And even if it's not, let's say you're doing a stile and rail door, I'd get in there and seal that as well. I'd close that off. Fire rated doors, again, have to be ordered from the factory. You would violate the fire rating of the door itself if you attempted to mortise that in the field, if the door was not prepped for it. Speaking quickly about how you would mortise it, I would use a large horsepower router that would give me a plunge ability. I would use a 2-flute carbide bit to the proper overall length that will give me the cutting depth that I'm going to require. I would be using I would apply to it a base. On the base of the router, I would put an aluminum L angle. And if I took that router, turned it upside down, now my base is here, I would bolt my L angle down to it, or put one on both sides. That would give me the space between the two of the door thickness. I'd clamp that on that door and I would just run it down. A small amount, 1/8 of an inch at first, and work that router bit deeper with every pass. The downside of that is you really need to make sure that your angle is not going to score the face of the door, because I guarantee that it will. You might want to get some laminate and glue it on the inside of your unit so that you're not scratching anything. Nothing is worse than taking a cherry architectural grade door and then scratching the face of it all the way down as you mortise it. So you need to be able to realize that your templating, your fixturing may affect negatively the face of the door in your attempts to process machining. When the factory's doing it, they're using a CNC tool that is going to hold the tool down via vacuum or with clamps, and that router, nothing's going to touch the door except the router bit. So it's a very elegant procedure. No one in a door manufacturer is doing this by hand that I can think of. Now let's just get to the installation instructions, revision 2018, and you can see in the drawings what it's going to look like when it's installed. They give away what your end plates are certainly going to look like. There's no questions about that. You are going to have to trim that bottom so that you're able to get this all installed. Okay. The mortise applied door bottoms are non-handed and can be used for both left and right hand installations. They can be. Put this on the right side, put it on the left side, doesn't matter. For ease of installation, remove the door from the hinges. Pop it off the hinges, lay the door down flat on your sawhorses, and then you're going to be off to the races. You clamp that down. You don't want the door to move. If you're going to do it by hand, you're really moving a lot of tool through the door, and the door is going to move on you as you try to do that. Step 1, if necessary, cut unit to match width of door. Do not cut from the end with the adjustment screw. Maximum cut is 2 inch. If unit is trimmed in the field, undercut the inner drop-down gasket bar from the end opposite the adjustment screw. The gasket bar should be 1/4 inch less than the external housing. If you notice, over here, the drop bar is recessed in. That's by design. Because when that bottom actually drops, it doesn't drop like this. It actually drops like this. Okay? So you're going to want a little bit of compression on this side of your seal material because it's going to work its way that way when it closes. Mortise the entire length of the bottom edge of the door. They're saying 11/16 wide, 1 3/4 deep. That's what I came up with. If you try to push it to 1 3/4, you're kind of in no man's land. It'll probably still work, but 11/16, that would be the one to use. Position the unit into the mortise. Once you've got it mortised, you're going to stick the unit in the mortise. The end having the adjustment screw should be flush with the hinge side of the door. Mark and drill pilot holes to install the mounting screws. The mounting screws are certainly included. Pre-drill your holes, install your screws, now you're in good shape. Mount the door on the hinges. Cut the gasket on the adjustable screw end even with the edge of the door, or a little shorter so that the gasket will not get hung up on the end cap. Sure. Turn the adjustment screw so that the gasket bar drops to provide a complete seal when the door is closed. Hang the door, turn this in, leave it hang out only 1/8 inch or 3/16 at the most. Test the door. Turn it out, eighth or 3/16. Get down and look. Is it a complete seal? If not, back it out a couple of revolutions. Test it again, and then stop when you've got it fine-tuned. Don't change it again. Apply your end caps probably at that point. I would apply the end caps after you test. You're not going to be able to turn the drop bar like that. Do not overextend the adjustment screw more than what is required to come in contact, just to come in contact with the floor or threshold, which will result in excessive wear and damage. Maximum drop is 3/4 inch. You're going to want to keep that drop to the smallest amount possible. You know, if you can do a 1/2 inch or a 3/8 undercut, great. Less of that, you know, area you have to fill with your automatic door bottom. When the screw is properly adjusted, position the end cap with the hex hole over the adjustment screw and attach to the door to lock the setting. Yeah, okay. So this will prevent it from turning. There are holes in those end caps. You got little screws for those as well. There's a 5th screw in that package, and they're probably going to get to this in a moment, the strike. Let's take a look. Now, moving on further, with the door bottom in contact with the floor, we've talked about that. Step 10, attach the remaining end cap to the door cover opposite the end of the unit on the lock side. For wooden frames, install the small protective strike plate where the adjustment screw contacts the frame. You're going to apply that to a wooden frame so that every time that you close the door, you're not going to create a divot in your jamb with that big piece of metal hitting it every time. That's probably aluminum. Yeah, that bolt's aluminum. But nonetheless, it'll create a divot. The rest of the installation instructions, we covered the 730 version. The rest of page 1 talks about the other models. So therefore, this document is works for multiple models. The lower left area of page 2 is going to give your UL certification, positive pressure tested. And be mindful that when you are installing hardware onto fire-rated doors, that your hardware is certified as either listed or listed and labeled as approved for use in the fire-rated opening or the smoke control opening that you're working on. This does not have any indication visually on it that it is fire-rated, meaning it's labeled, but it is listed, which means you, the inspector, the fire marshal, anyone can contact the factory and say, I need your paperwork certifying or endorsing that this model is compliant with such and such. That means that it is listed. A ball bearing hinge on the same door does not have a UL stamp on it anywhere, but it is listed. There is paperwork on file that could be produced and forwarded for purposes of showing compliance of a piece of hardware. Not every door bottom carries these same sort of requirements. Just be mindful that you're ordering the right unit for your application. I do believe that they are elegant solutions in spite of the fact that they do make some sound that you will hear if you pay attention to it. I think they're elegant solutions in the sense that everyone does have trouble with the proverbial shoe that's left in the opening. You push your door open, you've got a door bottom on the bottom. It will tear that door bottom up eventually. Automatic door bottoms allow you to really avoid any sort of problem like that. Finally, there is a link below this video to the manufacturer's page where you can pull up not only all of the Hager products that we sell, but also a link to the manufacturer's website, as well as a link to the full product catalog. Any questions on the 730S-MIL, that's mill aluminum. Let's look at the product catalog. Okay, they only make it in mill, and the reason is you're not going to see any of this, although you will see these end caps. So if you are looking for dark bronze, you might need to do something about that, because they don't offer it in anything but the mill aluminum finish. Any questions on this or any other Hager product, you can get to their catalog from below this video to the link to the manufacturer's page, where you can pull up that catalog, all the Hager products we sell, and a link to the manufacturer's website as well. Thank you very much.